Zoom's behaving a little better than it has been, so I think we might make it today. And then this afternoon, I hope to have time to experiment with that camera, which doesn't have to go through the internet. It just works with the computer so that I can just abandon Zoom except for situations where somebody wants to watch the class live. Okay. And I have there's some other columns that are relevant to this course. Okay, we'll talk about this in a minute. The homework, I basically ask you to make a big graph. Okay, some of you made small graphs, not real small. They weren't tiny, so they were serviceable. But when I ask you to make a big graph, make a big graph. Okay, graph should fill the whole page, and then other stuff on another page. And the graphs were well done, even the small ones. And they were, for the most part, well labeled. Now I want you to label X equals for every dotted line you make, okay? And above or below the graph, not within the graph. Save within the graph for things like labeling the coordinates and maybe even identifying your estimate. And, that's one thing. I had trouble on most papers finding what your estimate was and then the comparison between the estimate and the function. Okay, so it's just a matter of display. And I've got a bunch of papers to look at in 20 minutes, and I want to be able to immediately spot what I see. And as I said to a number of you, it's just a matter of communication. You're going to need to understand what it means to communicate. Okay, at least be able to communicate to me. Now you're going to find even dumber people to communicate with than me. Might be hard to find many, but there will be some. Okay, so learn the art of communication. I mean, it's a lifelong process. I'm still learning. Did you understand anything I just said? Okay, well, I'm not seeing a lot of blank looks. So if you're paying attention, maybe I got that right. Okay, well, so I didn't always see the comparison. I really wanted to see that you understood that the estimate you made matches the function that represents that graph, okay? Because that's really important, I think, for most of you for understanding how these transformations work. If you believe it, and then if you know how to write out what the function is using shifts and stretches and compressions and that kind of stuff and reflections, then you have a really good picture of things that will be especially valuable to you if you take calculus. But they're going to be valuable to you regardless, because you're learning to understand graphs. Even if you're not understanding the kind of graphs we're doing in this course, you're developing a much better ability to interpret and read and understand what graphs are telling you. And that's going to be important in almost anything you do, okay? Which is why we're emphasizing this. Also, you don't have to do much algebra, because I know that's a challenge. Coming out of COVID, your courses weren't always up to what they should be, and we're still developing the algebra, okay? So this is something you can do perfectly. You can sketch these graphs, you can label your horizontal lines, you can label your vertical lines, you can show your projection lines, the two lines through your estimated point, and all that stuff. It's what I really want to see. And I saw most of it on almost every paper, okay? So at the very minimum, I saw a good start. Get the rest of the details and bring it in Tuesday. If you had all the details, great. But there's only one or two papers that I would really say had all the details presented in the detail I like, okay? And it's not what I like, it's the detail I think you need in order to really get the message here. Fair enough? Whether I like it or not. That's not what's important. What's important is what's valuable to you. Okay. Now, switching gears, we find the intercept, axis, symmetry, and so forth of this function. So, actually, I'm going to want you to turn those in right now. Okay, so the quiz was find the intercepts, axis, symmetry, vertex of this function. Okay, now I'm gonna, you might not have done it in the order in which I'm gonna do it, but I'm gonna find the x-intercepts. And let me get over here because I've blocked the board last. Keep saying that, and I keep blocking. Okay. X-intercepts, they occur when y equals 0. So we solve 0 equals x squared plus 6x minus 12. Just putting 0 in here, pressing the f of x. I could say 0 equals f of 0. Forget I said that 0 equals f of x equals this, but I don't need the f of x at this point. I get a simple quadratic equation. Okay, that's going to be 36 and 12 squared, 145. It's going to be 180. Not square 12. Losing my mind. Okay, that's going to be 48. And that's going to be 36 and 36 and 48 is 84. Over 2 times 1. Everybody remember getting that? Is that what you got? Mm-hmm. Okay. Okay. Now here's my axis of symmetry. And I'll use that in a minute. But I'm going to write that out as then -6 over 2 plus or minus the square root of 84 over 2 equals -3 plus or minus. Well, I can write the square root of 84 as the square root of 4 times the square root of 21 over 2. And very quickly get -3 plus or minus the square root of 21. Now, if you're plugging this into a calculator before simplifying this, you really want to simplify this just for your own practice in factoring and algebra, because that's going to become very important. Okay, you want to simplify that. So that's the answer. Okay, that's the form the answer should be in. Okay, and then you can say that's approximately equal to what you get from your calculator. When you find the zeros, I want to see the exact zeros in simplified form. Okay. If they're not completely simplified, well, I'm not going to take 10 points off your problem unless that's what I'm testing. And that's not what I'm testing. Okay. Might only be a slap on the wrist, a point or two, but keep getting slapped on the wrist, and that's a letter grade or two. So you don't want that. Okay, so -3 plus or minus the square root of 21, which is approximately -3 plus or minus maybe 4.6, maybe 4.5. Of course, with your calculator, you can make that really precise. Well, that gives me 1.6 or -7.6. Now, 1.6 squared is 2.56. 1.6 times 6 is 9.6. 2.6 in ballpark, and 9.6 is 11.6. Minus 12 is pretty close to 0. Okay. So then approximation error, that gives me 0. And that gives me like 54 and like 48. Well, if this is right, that should be right. Coming up a little high, but actually that might be a little bigger. Yeah, it's plausible. Okay, so those are plausible results. And I just check that in my head. Sometimes you might, if it's really important, use your calculator. Plug this in here and see if you get zero. Plug this in here and see if you get zero. You're not going to get zero if you're using a decimal number, because the decimal number is never completely correct when you're doing a square root of something that doesn't have an integer square root, okay? Or a rational square root, usually it won't. But if you're really close to zero with these, then it's close enough, okay? It means you probably did it right. All right. So anyhow, there are the x-intercepts. Automatically, the y-intercept occurs when x equals zero, always. And for any function, it's not just something that you use for quadratic functions and not for other functions. And a lot of times, since you're used to using it for quadratic functions, you think maybe it only applies to quadratic functions, or you're not sure. That's okay to be not sure. And I'm telling you, always. So now you're sure, to the extent that you trust me, which is a little fuzzy. Okay, makes sense? Okay, so y-intercept when x equals zero, well, y equals f of zero equals 0 squared plus 6 times 0 minus 12 equals minus 12. The y-intercept is at 0, negative 12. Your x-intercepts, from what we saw here, are approximately, I'm writing this pretty small, I'm just writing approximate x-intercepts are 1.60 and negative 7.60. Exactly, it would be 3, negative 3 plus the square root of 21, 0, negative 3 minus square root of 21, 0. And you would want to write that out as well. I would have, but I don't have room. So I recommend that you write that out to be complete and have every detail, which is one thing that I'm emphasizing first with the assignment that y'all did pretty well on, extremely well. Want to get all the details, okay? So the details would include the exact solution as well as the approximate solutions. Well, now we've got that. Okay, except we don't have the axis symmetry of the vertex. Here's your axis of symmetry, x equals negative 3. I've said it again and again, it's halfway between the zeros. It's due to the plus minus, okay? Plus is on one side of the zero, the minus puts you on the other side of the zero at an equal distance. So the zero has to be halfway between, which means it's here. Okay. And now what's the vertex? It's a graph point where x equals negative 3. That actually, let me say that a little better. It's a graph point on the axis of symmetry. So x equals negative 3. You get the y coordinate. You plug that into f of x. Okay. The y coordinate is y equals f of -3 equals -3 squared plus 6 times -3 minus 12. That's 9, that's -18, so that's -24. Okay. Again, check me on that. That's 9, and -18 is -9, -9, -12 is -21. I'm pretty sure that's right. The vertex is -3, -21. Now we have our intercepts and we have our vertex. Now we can graph the function, and we hope everything makes sense. If we're lucky it does. I'm lucky it does, since I'm the one who just did it. Okay. Okay, so the y-intercept is at 0, -12. I'm going to set my scale by putting, notice that I'm labeling the line y equals -12. Okay. And at this point, I'll label on this side. It won't be in the way. It's 0, -12. All right. Now the x-intercepts are -3 plus the square root of 21, which is about 1.6. So I'm going to do this -7.6 first. I'm going to put that over here. Okay. And this is I'm going to use this vertical line. Okay. As opposed to dropping off a big scale on here, which is okay. It's valid, but let's back up to the problem you did for homework. You never had to draw an X or Y axis. You never had to label an X or Y axis because you'd labeled enough vertical and horizontal lines that you knew where you were. The X axis was out there in the ozone someplace. Okay, well, you could visualize where it is. You can make a smaller graph that puts it within the XY plane. Okay, because the graph is 14 miles that way and 398 miles that way. You probably don't even need the XY axis if you've labeled some of these vertical and horizontal lines. Okay, so if that's 7.6, 1.6 is between 1/4 and 1/5 of that. So 1/4 or 1/5 of that distance is maybe this distance. And the more accurately you can estimate that, the better. But you don't want to. Okay. Now this is x approximately equal to 1.6, -7.6. This is x approximately equal to 1.6. I've got room down here. It isn't going to interfere with my graph. To write this, the actual is -3 minus the square root of 21. And I should have the x equal in there. Actual x equals -3 plus the square root of 21. Just remind yourself that these are approximations. And if you use those approximations to do calculations, you're going to be off just a little bit. Okay. That's okay, as long as you use enough significant figures to get something that convinces you. Okay. So again, where are we? We found the intercepts. Now we've graphed the intercepts. We found the axis of symmetry. We haven't graphed it yet, but we're going to. It's halfway between the zeros, which would be about here. And if that's 1.6, it's very plausible. That's -3, right? And it's -3, probably should be a little bit more to the left, but we'll live with a little asymmetry. And I'm going to label this up here because my labeling's getting a little crowded down here. X equals -3. And that's our axis of symmetry. And now we got the vertex, which is at -3, -21. Now, first of all, if I've got these 3 points and I know that my low point is going to be on this line, I could sketch a graph. It'd probably intercept down here, about down here, wouldn't it? Okay, you know what a parabola is shaped like. You've been drawing good parabolas since the beginning of the class. So I'm expecting the vertex to be about here, but let's see, where would -21 be? Well, there's -12. And there's another -12, so that would be -24. So would this be about -21? If that's -12 and that's -24, let's go ahead and just write y equals -24 there, just to commit ourselves to where that would be. And here's where we thought the vertex would be. Well, between -12 and -24, -21's a good bit closer to -24 than it is to -12. So I'll just make my honest estimate. Here's y equals -21. Now see all the information I've got on this graph. You want to put all the information on the graph that you think is going to be relevant and helpful to accomplishing whatever it is you want to accomplish with that graph. Okay. Well, that means then that the vertex should be here. And that's kind of where I naturally want to draw it. If I draw a parabola from here up through here, I think well, I kind of messed it up there because my wrist is backward and the chalk stuff. I'll blame it everything but my own coordination. Okay. Anyhow, there we have a graph. That makes sense? And we can make estimates. It's not great. I didn't go through this point. I think I screwed it up here so it's not totally symmetric, but you have a representation and you all are drawing better graphs than I do. Okay. I could have started over here and done the same thing. Not great, but it's representative. And now I could use it to make estimates and compare my estimates with the function. So for example, if I want to estimate the value of the function when x is -5, that's -3, here's -5. So let's make an estimate. Now, we're going to have to do this. Here's x equals -5. And here's a dotted line that gives me my y coordinate, which is about halfway between -12 and -24. So I'll say that's about y equals -16. So at this point is an estimate, and I'm going to have trouble writing the word estimate in here without crowding the rest of the graph, which is why I ask you to do big graphs so you have room. Okay. I'm writing with big old clunky chalk and stuff like that, and I didn't make the graph as big as I could have. Anyway, so I'm going to have trouble finding a place to specify that this is an estimate. So I'm going to do it way out here. Estimate -5, -16. And I've labeled it. So now when I come around and look at your papers, I can tell what you made for the estimate. I mean, I kind of knew where it was supposed to be. Even then, I didn't always see it, but I'm pretty sure it was always there. Okay, so there's the estimate. Now, if I plug -5 into the function, if I square -5, I'm not even sure the function's showing, is it? All the way over to there, pretty much. I get 25 and -30, which is -5, and -12, which is -17. So I've done pretty good, despite the fact that I drew a crappy graph. Okay. Understand the process. I want you to know, and you understand the graph much better if you can do all that. Okay. So checking the estimate. That's close, and all this added comment, not as bad as usual. Fair enough? Okay, the vertex form just tells you what the vertical stretch is in the horizontal and vertical shift. Vertex form is y equals f of x minus h plus k. Okay, and a lot of people are writing that out. That's seeping into your minds. I've seen it on several papers. Okay, and it's not an insidious thing. It's not like some of those brain chips they're killing monkeys with right now. Okay, I say that with the knowledge that the brain chips are going to get safe one of these days. There's a good chance that a lot of you, even all of you, choose to get some. Okay. You know, I'll stick with what feeble brain I'm left with. I don't know. It depends on how feeble it gets. If it gets feeble enough, I might make a bad choice and choose to do that. Okay, well, it's probably getting there. Okay, well, how did I get the brain chips? I don't even remember how I got there, so I think I need one. Okay, maybe two or three, maybe a dozen. Okay, we're talking about vertex form. Somehow that morphed into brain chips. I really want another small board, but I think I have to save one because I still haven't recovered everything that we lost when Zoom crashed last time. Okay, let's see, where does the, come on, Zoom, keep moving. Okay. Let's see, it should move to the left of this mark. I'm gonna forget that. Okay. X is -3, -21. Okay. Horizontal shift is -3, so h equals -3. Vertical shift is -21, so k equals -21. There's your vertex form. Hopefully we're now used to the fact that the f of x being the squaring function, because this is a quadratic function. Now, this a times x minus h squared plus k depends on f of x being x squared. If f of x is e to the x, that's going to be e to the x minus h plus k. A times there, e to the x minus h plus k. Okay. Well, that's a times x minus -3 plus -21. Y equals a times x plus 3 squared minus 21. Well, the question is, what's the value of A? Well, the value of A for the vertex form is exactly the same as the value of A for the standard form. Okay. So it's this, and it's the same A for the vertex in the standard form. Because of course, when you expand this square, you're going to get x squared plus 6x plus 9. Okay. And you're going to multiply that by A, and you still got to get x squared because you got to get this. I mean, you just got to get your x squared plus 6x. So A has to be 1, but whatever A is, it's going to be the same here as it is here. So if you have this form, you automatically know what A is. So there it is. It tells you the vertex is at -3, -21. Because your shift is -3 units. Why is your shift -3 units? Because adding 3 to x shifts you -3 units horizontally. You need to put all that together, and you're either there or most of you seem to be very close to being there. Okay. So, put that together in section 3.2. It all comes together. And then we get to move into polynomials, which we're going to talk about now. We've already done stuff with polynomials. You've done well so far in the assignments in polynomials. Okay. The one you have coming up, or the two you'll have coming up for this weekend, are fairly involved. So we want to take a quick look at what's involved here. Okay. So now what did I do this for? I want to draw a polynomial with these intercepts. Now, I want everybody to give me either a thumbs up or a thumbs down. Okay, so everybody need to see thumbs. You're not sure, just okay, you can put 2 on there. Okay. Okay, so almost everybody's giving a thumbs up. Okay. So let's do another one. Thumbs up or thumbs down? Still up? Yeah, okay, that be that way. You don't know what you're doing it for, and it's fine. Actually, I was kind of hoping they come out the same. Okay. Now, hopefully you don't think you're giving me a thumbs up because I don't deserve it. This is for the graph. Okay. Thumbs up means that the graph is going to go up on this side and up on this side. Okay, well, you don't need to draw all the dotted lines in your graph, but make kind of a copy showing where these points are and draw your curve that represents a polynomial. Don't want to take too long with this. And y'all were pretty good with this last time, so I think you can do it kind of quickly. If it's a little bit sloppy, that's okay. Even if it's wrong, it's okay. I'll just correct what I see as wrong. Okay, everybody made a reasonable attempt, but I saw a lot of them that came down through here and up through here, and then came down through here and so forth. You can't go down through here because there's no intercept here. I wasn't specific about that. I clarified it. These are the only places you can go through. These are the only x-intercepts. Okay, so what are you going to do? You got to start up here and end up here and go through all of these points, but only through the x-axis here. Well, two things you can do. You could come down here and you could have a kind of a parabolic shape as you went through that point. Now you can come back up like so. Okay. Maybe you can have zeros of multiplicity too. And you've seen that if you've done the homework and the reading. And we talked about it last time. And we talked about the fact that at this zero, the function is essentially very close to this zero at x, just like a very specific quadratic function that we could easily determine. Okay. Okay. So we could do that. Alternatively, we could come down a little steeper through here and turn around here before we go down here. Turn around and come up through here. Okay. Now this is pretty much identical to what I did in the MDE 61 class, but we did it much more slowly. We spread this out for an hour, and we've only got like 17 minutes left here. Okay. So we're not going to be able to do all the details. So if you want to see all the detail of the reasoning, you can think MDE 61 videos right there. Assuming that I can post the darn thing, because Zoom or my system here would not complete the download yesterday. I had to do a Zoom link, which is a little, I prefer the YouTube link. Anyhow, you might see that again today if it's behaving that way. So I'm going to call this one P1 of X, and I'm going to call this one P2 of X. I'm going to say that, okay, P1 of X well, first of all, it has zeros at x equals -6, -3, and 4. So it has to have factors of x plus 6, x plus 3, and x minus 4. Now, this is because every polynomial can be factored. Okay? Not necessarily into linear factors. We'll talk a little bit more about that later. But in this case, it can. Okay? This is not the only polynomial. It's not going to be the only polynomial that could be drawn, but it's going to be a polynomial that could be drawn with the given characteristics. Okay? At the very minimum, it has to have factors of x plus 6, x plus 3, and x minus 4. Okay? And then there's some factor out in front, because this polynomial is not going to give you -26 when you plug in x equals 0. Okay. The other thing is, if I jump to x plus 6 here, then all this other stuff near x plus 6, all this other stuff, a and the value of x plus 3 and the value of x minus 4, it's just going to be some number when x equals -6. Okay. If x equals -6, I can plug numbers in here, and once I know what a is, I can figure out what the multiplier is, and that would just be a multiple of y equals x plus 6. That's a straight line. Well, this thing has a quadratic nature here, so that means I better have x plus 6 squared. So now this is some number, depending on what a is, multiplied by x plus 6 squared. That's a vertical stretch of the y equals x squared shifted 6 units to the left. Okay? Now you don't need to totally understand that, but if you can, it's going to be very helpful, because there are things you won't forget. I'm not going to test you over whether you understand that, but if you understand it, it's going to be to your advantage. So, and to your advantage in later courses. It's a little more sophisticated. It stretches your brain just a little bit in kind of a nice way. It's not beyond you. You might not have time to worry about it. Life is life. So it's not going to be on the test, but it's worth knowing. Okay, so I'm not going to say too much more about that, except to say that acts like a parabola, and it comes from this, so that's got to be squared. At least it could be a fourth power. It can come down here a little flatter, and up a little steeper and all that stuff. And I could do the same thing with the fourth power, but I'm just doing it with a square because I'm asking for the minimum that we have to have in order to come up with a function. Okay. I didn't even specify it had to be the minimum. I said come up with any polynomial. So you happen to come up with a fourth power there, as long as you do everything right, you satisfy it. Okay. Okay. Once you come up with these factors, we can easily determine A. How do we determine A? Well, if I know the value of X and Y, of course, this is Y equals P1 of X equals this. If the graph is Y versus X implicitly, so we'll make it implicit. There it is. Okay. If I say that this graph goes through the point 10, 5,093, then what could I do? Well, I could plug in 10 for X and 5,093 for Y. If I plug in 10 for X, I just get numbers here. Multiply them out, you're going to get some number. And you're going to have 5,093. So you're going to have A times some number equals 5,093. That's really easy to solve for A. You just divide 5,093 by whatever you get here when you plug in 10, and that's it. Now, that's easy. Even easier is if you happen to be able to plug in X equals 0. X equals 0 is a nice number to plug in. Okay. If you plug in X equals 0, then, well, when X equals 0, you have this point. So here's our y-intercept. It's 0, negative 26. Means if I plug in 0 here, I've got to get negative 26. What the y-intercept tells us is what y is when X equals 0. So y equals A times 0 plus 6, and that's not y. Y is negative 26 equals A times 0 plus 6 squared times 0 plus 3 times 0 minus 4. That's going to be 36, and that's going to be negative 12, and negative 12 times 36 is negative 360 minus 76, which is negative 432. Maybe. Question mark on that negative 432. Multiply it yourself. I don't care if it's right or not. You get the idea. It's going to be close to that if it's not that. Okay. I kind of think it's right. But so A equals negative 432. I write what I say. We get there quicker. Negative 432 over 26. Well, that equals negative 216 over 13. 216 is 6 cubed. It's not negative anymore because it's over negative 26. That's 6 cubed and 13 got no 6's in it, so that's the lowest one. Okay. So there's your P of X, P1 of X. If I've done it correctly, then you could take this to an online graphing program like Desmos or to your graphing calculator and draw a graph and see how you did when you made your curve, okay? Or you can see how I did when I made my curve. I don't think any of us are likely to have done it all that well. But at least one of us probably is. It's probably not me. Okay. So you'd be welcome to check that. Okay. It wouldn't be a bad exercise because it would convince you that this is true, but I'm not requiring it. Okay. Now, how do we do P2 of X? Well, a little more abbreviated form. That should be 3. Okay. So this one ends up squared because that's where the quadratic nature comes about. Okay. Y equals -26. Y equals -26 when x equals 0. So let y equal 26, let x equal 0. -26 is a times 0 plus 6 times 0 plus 3 squared times 0 minus 4. And that's going to be 6 times 9 is 54. And that times -4 is -216. That's 108 over 13. And that's in lowest terms. So P2 of x is 108 over 13 times x plus 6 times x plus 4. It's 3. I don't know why I keep wanting to put 4 there. Squared times x minus 4. That's simple. It's very simple. Okay. And it's kind of profound because, again, knowing the zeros and their multiplicities and the y-intercept, you can always write the polynomial. You just write the factors and you solve for a. And this works, what I've plugged in -26 for y and 0 for x, right? As I said before, if when x is 10, y is 5,073, okay, I could plug in 5,073 instead of -26 and 10 rather than 0. I'd still just get a number over here. That'd be 216a to solve for a. But I just get a number in front of a, and I'd get a number over here, and I just do a simple division, reduce the fraction. Okay. If the fraction is completely ridiculous, even the division completely ridiculous, maybe divide it out and round it off to 3 significant figures or something like that. Okay. You want to write the exact fraction, but then you can do an approximation. Okay. So 108 over 13 is the approximately 8.22. Okay. You check me on that. It's probably close. Okay, makes sense. It's not difficult. Now I'm just writing that down to remind myself to make note of it when I do a narrative of the video. Okay. The logic is simply that we first know that a polynomial can be factored. And if we have zeros, they come about from those factors. Okay. In order to get a 0 at x equals -6, I got to have a factor x plus 6. To get a 0 when the thing turns around, I got to have at least a square or some even power. 2, 4, 6, 8, 596, whatever. Okay. So there's a logic of that. We need to understand that if we don't have an x plus 6 in this as one of these factors, we're not going to get 0 when x equals 6. Nothing else will give us 0. And we have to have a 0 because all these things are multiplied. Okay. Then we have to know, of course, that the x-intercepts occur when y equals 0. That we need that in order to apply what I just said. So maybe we should have said it in that order. The other thing that tends to maybe get overlooked is what the y-intercept tells you. It tells you what the y-coordinate is if x equals 0. And we kind of emphasized that last time. Y-intercepts occur when x equals 0, x-intercepts occur when y equals 0. Make sure you've got that locked in because it keeps applying again and again and again. I think I said the same thing earlier. So there's the logic of what the y-intercept tells you. And you put that together and you get an equation you can solve for a. And of course, it's logical that a doesn't always have to be 1. Polynomial doesn't always have a 1x cubed or 1x to the 4th as its leading term. Okay? You have any number in front of its leading term, and that's going to be whatever a is. So we solve for a and we get the equation. Okay, well, a lot of that logic applies to any function, especially the logic of the intercepts. Zoom is getting really confused here. I'm going to